So hello everyone, welcome to my YouTube channel. For today's video I have a new video tutorial, and today we're going to talk about a little bit about FEM simulation or finite element method simulations. And I just wanted to go a little bit back to the basics regarding what simulations means, and I just want to make a new tutorial, a very basic tutorial, just to show you how you can start. Maybe you are a student in engineering, or maybe you are just a young entrepreneur looking to do some basic simulations out of some products that you are creating. And I just think a lot of people now is using SolidWorks. SolidWorks is one of the most used software actually for 3D modeling, because of its prices is really competitive and it's not so expensive as other, as from Siemens or from the Dassault System, as well as CATIA or Pro Engineering, and it offers a very different range of prices and capabilities. And I think that's why a lot of people and a lot of universities are using this and are taking advantage of these different modules that they offer and different prices. And I just think in general SolidWorks is one of the most used software, but I think there is a lot of people that still don't know what they can do, or if they can push a little bit further the design process and not just only creating 3D models. I think validation and simulation is a really important topic in engineering design and product design. So that's why I just wanted to make this video, and a little bit basic, and it's really for beginners. So if you're a student, if you are engineering student, if you are just someone that is starting with FEM simulations or with 3D modeling, I think this video can help you a lot. So let's start with today's video. I have prepared something very basic, and I think I like this a lot because it is something that you people can see in a daily basis life and in every day. And sometimes people trend to do some very crazy stuff when talking about simulations and finite element design, but we don't need to. Not everything needs to be really complex, like crash simulations or like automotive validation, and those kind of things are, of course, they are nice to have, but they require a lot of expertise, and this expertise, it can be acquired only through practice. So we are going to start with something very basic, but I think it's a very simple task. So let's start with. We start this video tutorial with some very basic fundamentals of finite elements method and simulations, and those are the main points that we are going to go through today. This is like the very basic outline of this video, and please don't forget those steps or these steps, because they are very important. And the first point, I'm going to start with a simple shelf. Today we're going to talk about just a very basic simple shelf, which is something that you hang in your wall and you fix with some screws and with some brackets, and it has a function. So I think it's a very nice thing, very basic. Probably most of you have something like this at your home, and I think it's just a nice thing to start with. So for this, I'm going to start talking a little bit about what are simulations, just a very brief introduction. And do not forget that simulations are a digital representation or a digital model of a real physical phenomena, environment or product. And these are things that you should not forget, and you should never forget. We do not do simulations just because we can do simulations, otherwise because we try to represent one physical or existent phenomena, object, product, process in a digital environment. That's why we make simulations. You can say to validate a process, to verify the functionality of a product, to get a better idea or a better understanding of a mechanical design. But do not forget this. Do not make simulations just for the purpose of make simulations. We make simulations because it has a meaningful representation in a physical world, and this is very important. You should never forget that all these variables and conditions that we are going to talk about later, they should have a meaning in a physical and real world. So that's what we are going to talk about this. We are going to talk about finite element method. You can take a look to another YouTube videos in order to get a little bit more understanding of how finite element method works. But for today's video, we're going just to focus in this SolidWorks tutorial. And we're going to start with the abstraction of an idea, and we're going to simplify the problem in order to put it in a basic steps, in some basic steps that you can use for as an input to our software, which in this case is SolidWorks Simulations. And we're going to use the 2021 version. This is the latest release. I think this is the latest Service Pack 4.1 I have. Yeah, that's the version that I am using, but this simulation should work probably from SolidWorks 2016 and above. Should give you no problems. My experience since SolidWorks 2009 is exactly the same process until now, so it changed nothing. So you probably is not going to make a huge difference which version of the software you're using, as it just needs to have the simulation module active. So let's talk about this. We have a basic shelf. It is hanging in our walls, and in my case, this is a picture that I took from at my home. This is actually the shelf that I have just above here, my monitor. And what is the purpose? The purpose is to have a very basic piece of good metal fixed in our wall, which is going to be fixed with some metal brackets or with some metal components to the wall, and as well to the plate, to the main plate. So I have this photo here, which is going to be like, these are the main brackets. This is how it's going to be fixed to the wall. So we have 2 screws to the wall and 2 screws to the plate. And this is how it looks this is how it looks as well. And it is pretty basic, but that's the most important thing of the simulation, that first we need to understand what is the purpose of this object or process in the real scenario. And this is just a general picture of how it looks. So let's go now again to the points, which are, today we are going to talk about this outline. Is going to be the geometry input, materials, boundary conditions, contacts, interactions, loads, mesh, and the execution of the job. And then we're going to take a look to the results. So let's start then with the geometry input. I do focus a lot in having an accurate as possible geometry, because having a reliable and accurate geometry can reduce significantly the simulation setup process. And we want to focus on doing the simulations. We do not want to focus in redoing some design or trying to fix and match an assembly and couple the geometry again. Usually, if we can have the geometry in the best possible scenario as we can, that is going to make so much easier as the simulation process. So let's start with the geometry input, and let's open here SolidWorks. Here I already have my 3D model. The 3D model, you can find it in the description below. I'm going to link maybe the links where you can download the files, and you can already have the parts as well as the assembly. In order to import the assembly, it's very basic. You just open SolidWorks, you just click on open, and then you find the assembly file. You just open it, and then you will be presented with something like this. Another point that I want to remark is that for this tutorial I am using a Dell Precision workstation, a tower workstation, but it is not the most powerful workstation that I have. It is just a basic 4-core CPU, 8 threads, and an NVIDIA Quadro P400 with 64 GB of RAM. Why I wanted to make it with a pretty much standard design computer, because I didn't want to use like a heavy computer, or like, because otherwise it's going, a lot of you, as me when I was younger, I was always like, yeah, but you are using a pretty high-end computer, that's why your simulation is just taking a few minutes. And I just wanted to use something that a lot of you people could use as well at the homes, or you can have access in the universities or at the schools. So this is what we are going to, this is how we are going to start. Pretty basic geometry here. And if you see, we have 2 main components, which are going to be the brackets. It is only one part with 3 bodies, and we are going to have the shelf itself, which is only one part, one body. And this is how it's divided, as again, 3 bodies for the brackets, 1 body for the shelf. It looks like this because I changed the appearances. Probably you are going to have them without the appearances. I don't know how it's going to be exported, but at the end it does not matter. It's only appearances. What matters is going to be the materials assignment later on the video. So that's for the 3D model. The geometry, as I said, you can download it. And then one important thing, if you don't see the simulation tab here, you need to activate it. How do we do this? We go to the tools, add-ins, and here you can select the SolidWorks simulation. Once you select it, this tab is going to show now on your SolidWorks menu, a graphical interface, and that's how we are going to start. To start the model, very basic, we need to define here a new study. New study, you just need to click here, and I do not recommend to use the simulation advisor. I think makes not that much sense. Even if you are a beginner, it makes not really sense. So let's start with defining a new study. New study, you can change the name here, for example. Let's do one tutorial 1. And we are going to make a basic static structural mechanics and static simulations. We are not going to talk about now from those other ones that are active here. If they are not active on your graphical interface, it depends on the licenses that you are using. In my case, I have SolidWorks Premium licenses. That's why I can use all of them, but doesn't matter. The static, probably it is integrated in almost every license of SolidWorks. I think even in the standard, probably, I do not remember. But yeah, we just select static and then click in the green mark to start. This is the presentation, or this is the basic presentation of SolidWorks simulations, which is this part here. The important thing is that you can see already that it is more or less structured. It's like defining just a step-by-step the simulation process, which is pretty basic. And I think that's a nice thing about SolidWorks, that it is pretty friendly, I will say, to new users, because you just only need to go step by step, defining these things that you need, and then you are going to get your results. So this is how we are now in the simulation add-in, and then let's go back to our PowerPoint to take a look what is the next step. Now that we have the geometry, as I say, we have 2 main parts. We have the shelf itself, and then we have the brackets components. Then let's talk about materials. This is very important. For any simulations, doesn't matter if you're a beginner, and medium or advanced, or an expert in simulations, to define the right materials is going to define if you are going to get an accurate, or even if you are going to get a result or not. Materials properties is one of the most important things that needs to be defined in any simulation process. It does not matter if it is finite element method or another kind of simulations. Having the correct material properties is going to help a lot in order to accelerate as well the simulation process. So the nice thing about SolidWorks is that SolidWorks includes some material libraries, and they are getting very good with each new release of SolidWorks. It already includes a lot of materials, and you can just literally click them and you can have access to the material properties. In this case, we're going to define 2 materials, wood and steel for the brackets. Yeah, and the main idea is to assign the correct material to each body or to each component. So let's go back to our SolidWorks. So now we have this. We have 2 parts, as I said. We have the brackets, which are 3 solid bodies, and we have the shelf itself. In order to define material properties, it's actually pretty easy. You just right click in the L bracket or in the bracket part, and then you apply materials to all bodies, which are going to be these 3 main bodies here of the 3 brackets. You are going to be presented now with the material library window, which is an amazing, as I say, it's an amazing set of materials that SolidWorks have already prepared for you, and then we are going to use a very basic, just like this, alloy steel. This is the most standard steel material that you can find because it is an alloy of steel, and you don't need to worry about anything else. Of course, if you know exactly the material that you are using, just take a look. If maybe you can find it here. If not, you can define as well prop materials by yourself. In this case, we're going to take only this basic alloy steel. You just need to click apply, and it's going to be already applied to the materials. If you see here already, the alloy steel is already showing there as the material of these parts. Then we're going to back to the shelf. Then we right click in the shelf, and then we are clicking apply and edit material. And then we take a look here to the steels. We don't want the steels, but we have as well, for example, woods. And then we have a different kind of woods here. In this case, I think it makes no sense to try and go defining the exact kind of wood that we have, because I personally don't know as well which is one. You just click select the balsa, for example, and then we already have the material properties. We click apply, and then the material is already applied as you see here. So if you notice, the material appearance change because now you have a defined material for the part, which I think is a kind of nice thing. SolidWorks always try to show you the beauty part of the simulation process. I think looks pretty good, looks pretty nice, and is a nice touch from SolidWorks. So that's already the first point. We already defined materials, and then we now need to define the boundary conditions. Boundary conditions is, as the name says, are conditions that define and limit our space, I will say, or phenomena that we want to simulate. And for this case, if you go back again to this main picture, as we already mentioned, we have one main condition, which is the support of the brackets into our shelf. So let's try to simulate that now. And we need to fix some things. Let's go back to SolidWorks again. And then if you see here, you have something that it's called fixtures. Fixtures is like the main boundary conditions of, in order to delimit, to make a limit or to fix things. And then we just right click in the fixtures, and then we are going to fix a geometry. Yeah, this is the most basic boundary condition, I will say, and it is the one that we are going to use as well in this case. For the fixed geometry, we can now select the surfaces that we already took a look into our main problem, and those faces are these ones here in the back of the brackets, and these are the ones that we're going to delimitate with our fixed boundary condition. So yes, let's now in this window of the fixtures, here we're going to be here in these surfaces in order to select our surfaces, and we just go and select the surfaces that we want. You do not need to make shift or to click shift or something like that. You just click on the three surfaces, and they are going to show here in the selected surfaces. And that's everything that we need to do for now. And then you just click in the green mark, and now we have a fixed boundary condition. That's the first thing. Let's go now and take a look back to the process. What do we need now? We need now to establish another kind of boundary conditions with those are contacts interaction. For this basic beginner tutorial, we are not going to talk about how really contact interactions are being made. Otherwise, we are going to use the automatic contact detection that SolidWorks offers, which I think is amazing, and it works very good in most of the cases for basic simulations. Even for advanced simulations, it works very good. So the contact that we have now in this case, it happens in between the surface from this bracket here and our shelf itself, and we have at least 3 contacts, but we are not going to define them individually. As I already mentioned, we're going to use the automatic contact a detection from SolidWorks. And in order to do that, for example, if we go click to these connections and then component interactions and then global interaction, we can click here and edit the definition. And if you see, we already have this kind of interaction which is automatically created from SolidWorks and this one is bounded. This bounded is going to be a global interaction happening in the whole system. As you can see, is all of this bounding box is like our system, and this automatically detection of contacts is going to be happening inside the system. If you take a look here as well, we already have a predefined gap range. This gap range is going to be like a distance, and if two surfaces that SolidWorks intelligently thinks that should be in contact because of the distance that they have, is going to assign global contacts to them. And in this case, because of the geometry is very well defined, that's why I was talking in the first point that having a good geometry is going to simplify a lot the simulation process. You already have kind of contact here, and SolidWorks gives you the possibility to you do not need even to define the contacts if you don't want. SolidWorks is going to do it by itself. So we just click in the green mark and it's already defining the contacts. Believe it, it's really so easy with this kind of SolidWorks contact global interaction, and believe me, it works pretty well. So now let's go back to the PowerPoint and let's take a look what is the next step. Now we need to define loads. Loads are going to be the loads or the forces that are going to be applying in our system. For this case, I imagine, just as an example here, that maybe if you have a shelf like this, we have, for example, here at home, we have some plants, some decoration, and other basic things that are not going to be so heavy. I suppose that we are now having here like around 20 kilos maximum, and it's already that much, but for the sake of the simplification process, I'm going to try to simulate 20 kilograms of force maximum in my shelf. If we put it in this way, 1 kilogram forces is equal to around 10 newtons. And for example, if we want to use a load of 20 kilograms, because of the plants and the decoration, we are talking around about 200 newtons. So 200 newtons is a force, is a load that we are going to apply to our system. So let's go back now to simulation in SolidWorks, and then we have this external loads feature. We just right click here and then we click on force. Into the force, we are presented again to this window in which you can now select the faces or edges in which the force is going to be applied. So we just select this surface here, and SolidWorks automatically detects that it's going to be applied normal to the whole surface. It's not going to be punctual, it's going to be applied to this whole surface. And here now you have if you want to make it normal, or if you can select a direction as well if you want. So in this case, it works just as it is. Now we are going to here now to define the units, and we talk about 200 newtons. We are already in newtons, and we are in the international system of metrics, and which now it works, and you just click the green mark, and now you have already defined your loads. So let's go and take a look to what do we need now. Now we have already our loads defined, and then we need now a mesh. A mesh is a very important parameter of finite element method simulations. In this tutorial, we're not going to go deep to talk about mesh, but you need to imagine that a mesh is a discretization of a body, of a system in a smaller elements, in which in these elements you are able to solve some mathematical equations, and it's easier than to try to solve it for the complete system. In this case, it's actually pretty simple because you already have a perfectly geometrical figure as your main body. But now imagine if you have a very complex geometry, the calculation of mathematical equations into those complex geometries is not so easy. There are no really equations that apply specific for that geometrical system. That's why we create a small set of elements that we know the form and shape and size of those small elements, of those mesh elements, and then we can apply those mathematical equations into those small elements. And that's why we mesh the geometry, because we want to have geometries that we know the form, we know the shape, we know the size, more or less, and you just need to apply the equations to those small systems, put them together, integrate them together, and then you have your results. So now we need to create this mesh. In order to do that, SolidWorks gives you as well a very good automatic mesh generator, which you just need to right click on the mesh feature and then create mesh. And then you are going to be presented as well now with this window. And to be honest, I always do fine because yeah, you are going to see later the difference, but I always do go to fine in the mesh factor. You can go as well to coarse, but I always, yeah, the best possible results you can get all with the finer mesh. And it's not going to make really a big difference in SolidWorks because the automatic method of creating the mesh is as well not the most complex for SolidWorks. So we are just going to select here in fine and click the green mark. It's going to start meshing SolidWorks, which it takes a few seconds only. And now you are going to have your mesh already here. And if you see here, as we mentioned, now you have a small set of elements. And for those elements, you know, as I mentioned before, the shape, the form, the size, and the mathematical equations that you apply instead of applying the equations to the whole system in order to compute the stresses or the deformations. You are going to compute them in each of these small elements, integrate them together, and then you have the results. If you see as well, the brackets are already meshed as well, and it looks good now. So now we have the mesh already. Let's take a look to our PowerPoint. What is the next step? Now the next step is the execution. And let's just recap very quickly what we already made. We already had a geometry, and the geometry already was given by me. We already defined the materials. We already defined the boundary conditions, which are the fixed geometry and the loads. And the contacts, of course, is already given by the global contact method from SolidWorks. The loads are already defined, and the mesh, we just created it. So it looks good, and these are the most basic fundamental things that we need in order to run statical structural simulations in SolidWorks at least. So now we just need to run the study. In order to do that, we just go here in the main menu, and then we just click run this study. And depending on your computer, it's going to take different time in order to solve the problem, but this model is very basic, and as I said, my computer is not even the fastest computer, and it's going to take maybe a few seconds, maybe 2-3 minutes. You just click run this study. It's going to start to solve in the background. So it took just a few seconds, and now we have already the results. Here we are presenting the stresses in the von Mises stresses. And if you take a look now, we have here our critical zones, and I think it looks like kind of correct now. I mean, if we take a look back here again, we can more or less see that the main stress, at least what I expect, is that the main stresses, the concentration of stresses happens in the brackets, because the brackets are the ones that are holding the whole weight of the system. So it looks kind of correct, and that's what I mean when you don't need to forget what is the purpose of your simulation. Even if it's a basic simulation like this one, but it already looks like correct and is matching a physical real process. And that's how it looks. If you see here, now we have the results. These are in pascals, and yeah, you can see that the blue ones is like the zones that are not really stressed, and the red ones are the zones that are getting the whole stress, and which looks kind of correct. Yeah, so that looks good. Now if we take a look to the other ones, the other two looks almost the same, which this just more or less validates what I was expecting. And if you are doing like very complex or really or if you have a product that depends on this, or you are the maker of these brackets, now at least you know if they are going to hold or not, and then you can make specifications, for example, for your product. So this looks good in the stresses. Let's go now to take a look to these displacements. And if you see here, SolidWorks is telling you now that the zones that are going to be more displaced are the ones here, which looks kind of correct as well, because if you have the table here and your brackets are in this side, then it's going to be more like tending to bend like this, and the far away zone of the brackets is going to be the one that is expecting the most deformations. And then again, what is most of the deformations? If you take a look to the scale here, to the results, the most deformed zone, it is around 2.6 millimeters. 2.6 millimeters is not that much. It's just really small, and it looks kind of correct. If you put 20 kilograms of weight in your shelf, it looks kind of correct, no? 2 millimeters. I think it's correct. And that's the nice thing about SolidWorks, that automatically gives you all the results, and it gives you as well an automatic scale of this. If you see something like really deformed and you think is wrong, don't think that is wrong. You just need to go to the settings. No, sorry, you just need to go here and then to the shot options probably. No, not in shot options, and then in edit definition. Yeah, edit definitions, and you need to make this true scale, because this is sometimes you are going to get like, but it looks very deformed and it's look like it's going to break, or is it not totally wrong direction? It's just the scale, and this is something that I don't understand since years. A lot of software, it tries to show you like an exaggeration in order to make it a lot more dynamic what you are seeing from results, but it's not the reality. So don't get scared if you see something totally different. You just need to click in the true scale, and then it's going to present you the right results. Nothing totally. For example, this is what I'm talking. For SolidWorks, this is correct. This is not correct. This is just a false scale, and this is totally wrong. This is totally wrong. What we're going to edit the definition as well, true scale, and now this is the correct form. And sometimes if you don't take a look to that, you are going to get scared, and then you are going to think that your simulation is wrong or your materials are totally wrong, but you are right. It's just SolidWorks trying to show you more, yeah, something to show you, to show later in a presentation something, but it's wrong. If you want to make some like a kind of animation of what you got here for results, actually, it's pretty easy. You just need to right click on the result that you want to animate, and then you just click in animate, which is going to create like a small time lapse depending on the simulation step, and it's going to make like a small animation of what is happening depending on the time, which I think this is kind of, it is a nice thing if you want to show to your professor in the university or to your classmates, or it may be the final presentation of your project. This is a nice thing to have, because if you have a different kind of deformation or system, it kind of show the idea of what is happening. So this is the animation. You can stop it here, or you can play again. You can define as well the points, how many pixels or frames do you want to make in the animation, and that's how it is. So I hope you enjoy and you like this video. This is just a very basic tutorial, a very basic FEM tutorial in SolidWorks, and I think it's a nice thing if you are able to validate some designs and to play a little bit with SolidWorks simulations, because it's a different kind of engineering field, I will say, not a word, but it's that kind of different field, and it can help you a lot if you're a student, if you're a young engineer, if you are a young researcher, in order to validate and prove some of the designs that you are making. And it doesn't need to be really complex, or you don't need to use a very high expensive software like Abacus, like ANSYS. SolidWorks, for example, most of the universities have a contract with SolidWorks, with Soul Systems, and you can get a student license from SolidWorks, and it includes already most of the cases SolidWorks simulations. I think it's a pretty nice thing to have. And If you have any questions in order to make basic SolidWorks simulations or any other kind of simulations in SolidWorks, let me know in the comments. If you have questions or problems regarding this specific tutorial, write me as well in the comments what problems are you having. Maybe depending on the version you are finding different kind of procedures. And the link, as I mentioned, I will link below the components that you can direct download them, and I will put it for 2021 as well as an step file. Maybe if you have an older version of SolidWorks, it works as well. And just let me know if you have problems as well. Let me know if this tutorial helped you, and I will try my best to make more advanced and complex tutorials in the time. So thank you for watching. I hope you liked this video, and see you until the next time.